let's talk a little about the format of the NEDC. The NEDC consists of 4 parts. The design proposal, which is roughly worth 15% of the overall scoring. The academic poster, which is roughly worth 22% of the overall score. Symposium, which is worth 29% of the overall score. And the technical pitch, which is worth 34% of the overall score. Now let's take a closer look at each of these design elements, beginning with the design proposal, which is a non-technical overview of the project, from the specific challenge and user base to the final design after multiple prototype iterations. The design proposal tells the story of your idea and what your ultimate product became. Next is your academic poster, a visual overview of the project that highlights the design process that is judged a week before the competition, but is used as a primary visual aid for the symposium. Next is the symposium, which is a poster session using the STAR method to engage judges in conversation about your project, and which makes you think quickly on your feet as judges choose randomly from a list of potential questions. Last but not least is your technical pitch, a presentation to judges that demonstrates your knowledge of the project and design process that every team member must contribute to. Now, at the heart of every single one of these design elements is your idea, which is taken through the engineering design process as you define your challenge, research your solution, specify your requirements, evaluate your design choices, develop a prototype solution, and ultimately test it. For the purpose of this workshop, we'll be using the foundation of the engineering design process, but as you can see from the simplified version on the screen, the process moves through the steps of define, ideation, prototyping, and testing. As you move through each step, you'll have opportunities to apply what you've learned from previous iterations, meaning earlier versions of your idea. Each cycle builds on the last. For example, while building a prototype, you might realize that your original idea doesn't work as expected. Maybe you don't have the materials or the technical knowledge to make it happen. That's okay. You can revisit the ideation phase to come up with new, more workable solutions based on what you learned. Similarly, a prototype that does work might inspire a new direction or improvement. And testing can also give new insights that send you all the way back to the define stage to better understand the problem. While it might sometimes feel like you're starting over, this is actually a natural and important part of the design process. Very few ideas work perfectly the first time. Nearly every design we rely on today has gone through multiple rounds of revision and testing to become what it is. Plus, for the NEDC competition, you're required to document multiple iterations of your project, so even small changes or refinements are valuable steps toward improving your final product. While the engineering design process should be at the core of how you develop your idea, it's equally important to remember the human aspect of design, making sure your users' needs are the top priority, not just during design, but also during testing. In some cases, you might be part of your target user group, but it's crucial you also understand the experiences of others outside of your immediate perspective, because ultimately, you're designing for a community, not just yourself or your team. This is where the human in human-centered design comes in. It's a creative process that places people at the heart of every step, understanding their challenges, imagining solutions, testing ideas, and improving them based on real feedback. While it mirrors much of the engineering design process, human-centered design adds an additional stage: empathy. This means taking time to truly understand users' needs, emotions, and challenges before defining the problem. By adding this step, you gain an advantage, because as you learn more about users during the define stage, you can refine both the problem and the solution. This empathy also becomes valuable after testing, as feedback helps you improve your design even further. A simple example of this comes from our Harmony Touch team, which won the Middle School National Championship in 2025 for the National Engineering Design Challenge. Their initial idea was to create a device that would let members of the deaf and hard of hearing community experience music through overlapping physical vibrations that represent layers of sound: melody, harmony, rhythm, and bass. Originally, users placed their hands on the device to feel the vibrations. But when the Harmony Touch team tested it with students at the California School for the Deaf, they discovered a key issue. Users needed to keep one hand on the device, which then prevented them from communicating freely through sign language. That feedback, gained through testing and empathy, inspired the team to redesign their prototype as a wearable glove, freeing the hands and allowing users to experience the music and communicate naturally. This is a perfect example of how empathy and iteration lead to innovation.